a series converges only for one value of x and diverges for any other value, and so the radius of convergence is equal to 0. Okay, let me show you another example that is way more typical, and it's very much like examples that you will have to solve for homework and for the midterm. So example 2, let's investigate the series 1 to infinity x minus 3 to the nth divided by n. So again, we are using the ratio test. Rho is going to be the limit, n goes to infinity, absolute value of a n plus first divided by a nth. This is going to be the limit, n goes to infinity. Okay, so because x could be negative, we are stuck with absolute value, but then we can carry all the positive factors outside of absolute value. Okay, so ax plus 1 is x minus 3 to n plus first divided by n plus 1, and then we are multiplying it by flipped a nth, so n divided by x minus 3 to the nth. So what we get 1x minus 3 left over, and that's the only guy that could be negative, right? So we will have the limit, n goes to infinity, x minus 3, and then times n divided by n plus 1. Now x minus 3 does not depend on n, so we can factor it out. X minus 3 times the limit n to n plus 1, and this limit is 1, so we get x minus 3. What do we do with x minus 3? Remember what we computed. We computed the ratio for convergence divergence test. So we know that if this rho is less than 1, so rho is equal to x minus 3 when it's less than 1, your series will converges. What does it mean for x? So if let's just draw geometrically. So x is equal to 3. If we come one this way and one this way, so we don't know exactly what happens when rho is equal to 1. So we don't know what happens at the points x is equal to 2 and 4. But we know that inside this interval, if x is anywhere here, we would have convergence, and if x is outside, so when rho that is equal to x minus 3 is greater than 1, our series diverges. Now we have to manually investigate what happens when x is equal to 2 and when x is equal to 4. And we can also remember the theorem. So we would have x minus a less than r, right, where r is convergence radius. So this is our radius of convergence. Radius of convergence. Okay, so when x is equal to 2, we just substitute this value into the series. So we're getting 2 minus 3 to the nth divided by n, and we are getting minus 1 to the nth divided by n. Do you recognize that this is alternating harmonic series? And we do know that it converges, and it converges by alternating series convergence test. And this is just one of those series that you intimately familiar with, right? converges. Okay, so the point 2 is good. Now let's check x is equal to 4. We would have 1 to infinity 4 minus 3 to the nth divided by n. So we get harmonic sequence 1 to infinity 1 over n, and it's just harmonic, and it's p series with p is equal to 1, so it diverges, and we know that coharmonic series diverges, right? Diverges. So in the point 4 we would have divergence. So now we are ready to present you with convergence interval. So we would say the interval of convergence is x in 2 belongs and 4 doesn't. So the radius of convergence r is equal to 1, and the not function, series, the series diverges for x in from minus infinity to 2 is not included, and united with 4 included plus infinity. Infinity is never included. We would always use parentheses. So that's a typical example, and this is something that will pop up on the exam.